Hi, welcome back. In this video, we're continuing to talk about graphing logarithms, specifically transformations. So I can write my transformed function y as a times log base b of x minus h plus k, where a, h, and k are exactly the same as they were for exponential for all of the other transformations we've done. So this a is going to be a vertical stretch or shrink. If a is negative, we'll flip our graph across the x-axis. H is going to be a horizontal shift. In this case, when we're thinking about what we are shifting horizontally, a key thing is that we have this asymptote here. So if I shift my graph one way or the other, this asymptote is going to move along with H. And K is going to be a vertical shift up and down. So let's kind of look at what happens to a graph when we have some transformations that have to happen. So here I have 3 log base 10 of x plus 1. So I want to start by first identifying a, h, and k. So a is going to be 3, h is 0, and k is 1. So sometimes it can get a little bit confusing if there are no parentheses. Just that first thing after log is inside the log. This 1 is outside the log. If this one was inside the log, there would have been parentheses around x plus 1 to indicate that that whole thing was inside. So this is a plus 1 for k. Our base here is 10 and our input is x. So we're going to use the input here. Our input needs to be positive, so that is x is positive. So our domain is from 0 to positive infinity. The domain gives us our asymptote at x is equal to 0. So I'm going to go ahead and graph that as a dashed line and label it. You have to do this. You must do this all the time. And now I'm going to be thinking about some convenient logs. And if we remember back to our previous examples, we were looking at the points 1 over b negative 1, 1, 0, and b1. So basically, convenient log expressions we know kind of start with, we know 10 to the negative 1 is 1 over 10. We know 10 to the 0 is 1, and we know 10 to the 1 is 10. So I'm starting with 3 exponential equations that I know that are convenient, and I'm going to turn these into convenient logarithmic expressions. So this becomes log base 10 of 1/10 is equal to negative 1. Log base 10 of 1 is equal to 0. And log base 10 of 10 is equal to 1. This is where it's really important that we remember how to go from exponential to logarithmic and back again. We need to make sure that we're doing this. This here is my input. So in this case, my entire input is x. So my entire input here will be 1/10. So if I input 1/10, this gives me 3 times log base 10 of 1/10 plus 1. I now know that log base 10 of 1/10 is negative 1. So this becomes 3 times negative 1 plus 1. Negative 3 plus 1, this is negative 2. So I am using my convenient logarithmic expression to help me figure out what my input should be so that I can do the math easily. If I just start picking points at random for x, I'm not going to be able to evaluate log base 3 of 7. Or I'm sorry, log base 10 of 7. That's not a logarithmic expression that I can simplify off the top of my head. I'm going to need a calculator. So I come up with these convenient logs to help me. So now log base 10 of 1. So this is my input, which is equal to x here. So I'm going to put 1 in, and I get 3 times log base 10 of 1 plus 1 And I know that log base 10 of 1 is equal to 0. So 3 times 0 plus 1 is 0 plus 1. This is equal to 1. Now, in this case, this is my input, which is x. So 10 is now my input, is equal to 3 times log base 10 of 10 plus 1. And I now know that log base 10 of 10 is 1. So this is 3 plus 1, which is 4. So now I'm going to go ahead and graph these. So I have 1/10, -2, which is going to be pretty difficult to graph. I'm just graphing it right next to the x-axis, or I'm sorry, the y-axis. I have the point 1, 1, and I have the point 10, 4. So there we go. This would be the graph log base 10 of x stretched vertically and shifted up.